Hello everyone, this is the first lesson recording for IM1 September 9th, 2020. We started off with taking the quiz number 2 on absolute value, evaluation expression and solving equation. If you are absent, then you need to contact me as soon as possible to arrange for a makeup quiz. Alright, so I sent an email yesterday about asking if you do not have a smartphone or some other reliable and quick method for uploading your work in Canvas, we're going to try to get you a smartphone. It's not going to be a new one, so don't contact me if you are just not happy with your smartphone that you have, but so that you will have some means to upload your work on Canvas pretty easily and reliably. And I'm assuming Chromebook is a little bit difficult, so if you just rely on Chromebook to take pictures, can you send me email me, and I'll see what they can do for you. All right, what are we doing today? Well, where have we been? We've talked about functions as function machines with input and output, and we've also learned the new function notation f of x, and you can see this function machine we are starting to use f of x to indicate what the output is, and this is a function rule, and the input was x is equal to 3, so we can represent the output as f of 3 is equal to 8. Okay, now we're going to continue with the study of functions, but today what we're doing is we're going to investigate how functions are used to describe situations. So, and use function notation to understand the situation. And to begin, we are going to watch a video. Okay, so watch what's happening. All right, this one has no sound actually. So we are going to graph how the water volume changes with time. And look, the person is pouring the water into the jug, and we're going to see how the volume changes over time. And that's what's happening in real time. And next, they're going to go a little slower so that we can figure out how it is changing in a slower fashion. Okay, look what's happening at time 5 seconds. How far is 6 seconds, 7 seconds, 8 seconds? That's where they are after 8 seconds. 9 seconds, 10 seconds, 11 seconds, and 12 seconds, and 13 seconds, and 14 seconds, and 15 seconds, and that's where they stop. Okay, now they're going to try to graph this. Okay, see how the volume is changing. It's increasing. So it's that line is where the height of the jar. Okay, and that's the graph that they came up with. So you're going to sketch the graph to represent the amount of water in the jug over time. So if you open up a Desmos, and I'm going to put the link in the chat. So if you were absent, then you are going to open this up, go to student.desmos.com, and then you're going to put in the class code, and it's going to, you're going to do the first card where you are going to rewatch the video, and then you are going to graph the graph that they graphed. Okay, I'm assuming you've done that. So let's talk about this a little bit. Okay, so this is the amount of water in a jug is a function of time. So this represents how the amount of water in the jug is a function of time. What does that mean? the input was the time, okay, or we call that independent variable. And if you look at the graph here, the time is on the x-axis and time is changing. The time is increasing because time, I suppose, it continues always, okay, and as the time increases, the water volume also increases. And at what rate? Did it go really fast or did it go really slowly? And that will be determined by the slope. The slope, how steep it is, will tell us how fast the water was poured or how slowly the water was poured. And if you recall, at different times, they figured out where the height of the water level was, and they graphed that. So, and the output is the y-axis, and that is the dependent variable. Why do we call that dependent variable? Because it's a variable. That means variable just means something that is changing, but it depends on how it varies, depends on the time that is passed. Okay, so it is the amount of volume depends on the time, so that's why the y-axis or the output is the dependent variable, and the output is the amount of water in the jug. Okay, all right, so why isn't the input just amount of water being poured? Well, yes, we can do that. We can represent that as the input, but it's not a very interesting function if you just do that. However, if you have the input as the time, you can see how, as the time passes, how the volume changes. So when you look at this graph, that is the graph from the video, what questions can I ask? Well, you can ask how much water is in the jug at 6 seconds. Okay, so we're interested in 6 seconds. What does that mean? We're talking about time, aren't we? We're not talking about the water volume. We're talking about time. And we're talking about 6 seconds to be precise. So when is 6 seconds? This axis tells us where how many seconds has passed. And this says 6 seconds is right here. Okay, this is 6 seconds. That means where is the graph at 6 seconds? So I go up where the graph is, and this is the point at 6 seconds, where the graph was at 6 seconds. So if I go to the left like so, how much water did we have? Somewhere between 200 and 300 milliliters, right? It's actually 240 milliliters. Okay, so that's, whoops, I don't mean to touch that. Okay, when does the jug have 100 milliliters of water? Okay, so the second question is asking when. So we're looking for the time, but we do know how much volume. We have 100 mils of water. Where is 100 mils of water? We're not talking about time anymore. We know the volume. So 100 mils of water is right here. And so then we go across, find the point on the graph. The graph is right here. And we know that if I go straight down, we know that it's somewhere between 2 and 3 seconds. So I'm going to say about 2.5 seconds. Okay, so we know that at 2.5 seconds, the water level was at 100 milliliters. That's what we just said. Okay, so now I want to type in private chat. When does the jug have 500 milliliters of water? How would you figure that out? Just look at what we've just done, and can you give me the time when the jug had 500 milliliters of water? Okay, all right, now let's move on. Water in the jug using function notations. Now we're going to move on to function notation of what we've just seen. Okay, remember that this is the amount of water in the jug is a function of time. So the output, the amount of water in the jug, is a function of time. It's a function of time. Function of time. This is the input. This is the output. and the input was the time, which is the independent variable, the x-axis, and the output, the y-axis, is the amount of water in the jug. So I am going to name my function w of t. This is the new function notation we learned. Remember, w, whatever the letter we use, we can use f, you can use h, we can use uppercase, lowercase, whatever, but it represents the name of the function. What's inside the parenthesis represents the variable, so in this case t represents the time. Okay, and w, what do you think w represents? Yeah, it's the water. Okay, it's water volume. Okay, and when you put this together, w of t together represents the output. So let's, instead of just calling it y, we can call it w of t as output. And so how much, so instead of saying how much water is in the jug at 6 seconds, now that we're calling it w of t, we can represent this question really simply as what is w of 6. Okay, this English phrase, sentence, or question can be represented as w of 6. So w of 6 is what is the output when the input is 6. When the input was 6, what was the input? When the input was 6, that means the time was 6. What was the output? It was between 200 and 300, and we said it was about 240. Okay, so it was about 240. So how are we going to represent this in the new function notation? We are going to say w of 6, that when the input was 6, what was the output? It was 240. So this simply states that at 6 seconds the water level was 240 milliliters. Great. So I want you to stop the video and copy this down, because you're going to need this to represent it. So I want you to try to copy down the graph as well as you can. So what you can do is you can draw this graph, and maybe you can come up with 10 seconds having approximately 420 milliliters of water, and then draw a straight line going from 0, 0 all the way. Okay, I'm going to assume that you are done with copying it down. Alright, so then tell me, what is w of 10? What is w of 10? Can you give me your answer in private chat? So w of 10 means what, when the input was 10, what was the output? Input was 10, what was the output? Input was 10, output was little over 400, but less than 500. Okay, so it's, I would say about 420 milliliters, and you do need the units to go with that. Okay, so this question was asking what is the output when the input is 10, and w of 10 is about 410 milliliters. Great. Alright, so then what is t when w of t is equal to 600? Okay, so we're going the opposite direction. Now we are told that w of t, what's w of t together? What is this? This is the output. When the output was 600, we're looking for t. So when the output was 600, we're looking for 600 going over here, and then t is a little over 14 seconds. Okay, so I would say about 14.5 seconds. Okay, and please pause the video and copy this down. And now, can you put in the private chat, what do you think is the w of t of 300? That means we're looking for time. Okay, when is a translation of this question is, what is when, at what time, how is the volume 300 milliliters? So please pause the video and answer the question. And the time was 7.2 seconds. Okay, I'm going to stop here, and we're going to do the next activity in the next video.